So I'm going to be talking today about a concept that you might have not heard yet. It's completely new. I haven't heard this term mentioned, throughout the event yet, or even in the industry. And that concept is AI, right? So now more, seriously, right? We're talking about AI, and sometimes it is presented as a magic thing. So I want to sort of demystify this concept and explain it down into very simple, terms and principles, right? I'm not going to go through algorithms or models or anything like that. We can talk about that in any other time. But I want to bring this down into what are the key principles, what are the key reasons as well why AI is relevant for us. This is not a product roadmap presentation. For roadmap, you guys have Omar somewhere here to ask for him. But all the concepts that I will show in the slides, we have prototype code or demos, right? So what I'm going to show is real. It's not a fantasy. It's not just a PowerPoint where. So there is a lot of opportunity here. All right. So I think I should put the sunglasses here. But hey, let's hear what is the industry saying. What are you saying? What are your leaders saying about AI, right? Plan, build, and operate. AI is not just about the operation part. It's about all the network lifecycle. It's about all the decisions that we make, as we plan, design, build, and of course, operate the network. It's not about real-time data only. It's about looking at the data that we have from the past and maybe being able to learn or predict something of the future, right? It's analysis of past incidents. Autonomous. We've been yesterday hearing a couple of presentations and multiple times the concept of autonomous network. We're talking about that. Why now, right? We were talking about automation, automated. Now we're talking about autonomous. What is different? The difference is, now the autonomy means some system is making decisions, right? That's new. Generative AI. We're talking about generative AI all over the place. Why is this relevant? What will it bring? Part of it will be simplicity, like in layman terms, right? So we'll discuss about that as well. And there's also a very important aspect, right? That AI might make network engineers, better professionals, right? How to make a good engineer great. And that's all about, your professional evolution as well, your careers. You're all network engineers. So I think there's also a big aspect here, or how AI is going to impact us from a, personal and professional point of view. Another term that we hear frequently for many years is AI ops, right? Originally coined by Gartner in 2016. It's been used in a lot of different environments, IT, security, application, of course, networking, right? But because we are all engineers, let's try to break AI ops down into some easy equations so we can understand actually what are the ingredients behind AI ops. First of all, it's about how do we transform data with algorithms into operational insights, right? Things that we didn't know. Now, how with algorithms we can, transform, process the data that we get from the network into operational insights. But operational insights by themselves are not that useful, right? What you want is to make decisions. So now we need operational insights with knowledge, right? We can then take decisions. Where does that knowledge come from? Most of the time it comes from us, people, right? Or experience or background, right? With the operational insights that we get, we can take decisions. What do we need to do in the network? How to fix something? What is the best design? What is the best software release? All sort of decisions. But the decisions, again, themselves are not that useful if you don't enforce them, if you don't transform them into action, right? So then you need automation tools to take those decisions and transform them into actions. And of course, the actions, once executed, will produce more data, and this is the whole cycle that actually Gartner was explaining about. And there are strong opportunities to leverage AI in all the key enablers for the outcomes that we want. The outcomes are insights, decisions, and actions. But the enablers are algorithms that allow us to transform the data, knowledge, how we can leverage AI to automate knowledge. We'll talk about that in the session. And also how we can use AI to facilitate adoption of the automation tools, to make it more easy for you to use automation tools. One example, if you have to generate a workflow or generate a Django model or generate a template in any automation tool, can we use AI to facilitate that process, to maybe generate it automatically for you? So those are examples about how AI can help. And you will see moving forward, as we evolve our product portfolio, that we will start to leverage AI in all these different fields. Algorithms for data, knowledge automation, and how do we facilitate the use of our automation tools with AI. But let's step back a bit, right? I started talking about AI ops, but why? Why do we even need to talk about this now, right? Why we were talking about, this is about automation, this event. Why are we talking about AI, right? It's a very valid question. And I think the reason is here, right? We all are in the middle of a perfect storm. And it's going to be hard to navigate through it. And this perfect storm is the combination of several things that are going on, right? We talked yesterday about complexity, right? Of course, there are things that we can do to simplify the architectures and so on, like SRv6, et cetera. But it's almost a fact that networks are more complex than ever, right? Measured in terms of scalability, number of technologies, even multi-vendor, et cetera. So it's definitely more complex than ever. But at the same time, what users expect from the network, the expectations are higher than ever. Again, you can measure it in the reliability they expect, the performance, the agility, right? Measure in any of the KPIs of your choice, but they expect more from the networks that you are running or you are operating. And then the people that you have to manage and operate these networks are fewer than ever, right? So it's a perfect storm, and it's actually probably trending even down due to the OpEx constraints. So how do we navigate through this perfect storm, right? Anyone? How do we navigate through this? Anyone wants to give an answer? Actually, I don't see much, but no answer? Please, one answer. Okay. Yeah, probably it goes there, but it's actually much simpler than that. It's automation. That's what we are here in this event. It's about automation, right? But it's automation at an unprecedented scale, right? It's not just what we're doing here. We need to reach a much higher level of a scale of automation to navigate through this. And now the next question, of course, is how do we get to that scale, right? Any idea how do we get to this higher scale? Automating more, right? We need to automate more to get to this scale. But automating more doesn't mean doing more of the same that we're doing. Because if we do just more of the same, we will not get there. And why is that? Because behind every activity, every task on the network lifecycle, again, design, plan, build, operate, any task, there are actions and there are decisions, right? But from a network automation perspective, the focus historically has been primarily on the actions. So we have been automating actions. We have been automating a software upgrade. We have been automating provisioning. We have been automating configuration. Those are actions. But actions and decisions are the two sides of the same coin, right? And they go together. And we have technologies, we have product solutions to automate actions. And the way to automate decisions is with data, algorithms, and knowledge, as I was referring earlier. So how do we get to the scale that we need? If we continue doing or focusing primarily on or only on actions, the decisions will become the bottleneck, right? Because the decisions depend primarily on the people. And what we need now is more decisions, better decisions, and faster decisions. It's as simple as that. How do we get there? Maybe we hire more people. Can we multiply the amount of people that you guys have in your organizations for 100? Probably not, right? probably there's no budget for that. And even if there was, you would probably don't even find so many skilled people to do that. So what's the option? Well, the option is, we need to use technology to the point that we can delegate complete tasks, right? To automate both the actions and the decisions associated to those tasks. So we can actually augment what people can do with some sort of intelligent agents, right? Agents that can make decisions and that can automate actions. So go back to the original question, why are we talking about AI? Because AI is what unlocks decision automation. And decision automation is what we need to navigate through the perfect storm. So if you are wondering why in this event are we talking about AI and why are we going to continue talking about AI moving forward, it's because AI is just a natural part of the next generation automation, because we need to embrace decisions, right? We just cannot ignore that anymore. One very simple example, software upgrade, right? Software upgrade, we've been in one way or another automating the process, the action of the software upgrade itself with a method of procedure, with a workflow engine. We were talking about yesterday how we can do it with our workflow engine in Crosswork, right? But around or before the software upgrade itself, there's a number of decisions that you guys take, right? Among others, when I'm going to do the software upgrade, right? Or even what software release I'm going to upgrade this device to, or what is actually the MOP, what is the process that I'm going to use, et cetera, et cetera. Taking all those decisions at small scale by people or somehow manually, it's okay. But at very large scale, it's probably not going to be okay, especially if you need to make sure that there shouldn't be any conflict, any collision. You should properly upgrade every router and not upgrade routers simultaneously that you should not, and so on, right? So this is just an example of how, when you want to do this at scale, you need to start looking at how do you automate those surrounding decisions or previous decisions associated to the action that you want to automate, right? And this is actually one of the use cases that we are working on. But what do we mean when we talk about AI? Are we talking about LLMs or generative AI? No, or not specifically. We're talking about everything. We're talking about all the different techniques under the toolkit, what AI is. AI includes machine learning, which is a part of algorithms that learn from data, and this includes, of course, generative AI and other techniques. But there's also non-machine learning-based techniques within AI that are extremely useful, and we are also going to use them. We're never going to be algorithm-centric. We're going to be problem-centric. Every problem that we have, we'll use the right tool for the right problem, not the other way around. So when you hear or when you see in this presentation or you hear us talking about AI, we're talking about all this, right? Not just generative AI or LLMs or anything in particular. So back to the AI ops, the key outcomes that we want, right? That all this is about insights, decisions, and actions. These are the fundamental outcomes that we need to achieve, and the fundamental building blocks from automation moving forward, right? Where historically the decision part has been dependent on people, so basically it was not automated. But now we need to start looking at how do you automate it. But before automating decisions, we need to have a strong foundation, right? And that strong foundation depends on having a strong insights framework and a strong action automation framework. And this is what we have been focusing from a portfolio perspective over the past years by building a proper portfolio of components and technologies that allow us to provide that visibility and insights as well as the actions that can be automated so that we are ready for the next step. The next step is about decisions, right? And it's not just us saying that, right? The whole industry is talking about now, how do we get to this concept of autonomous network? TM Forum has defined, the framework for the autonomous network, the different levels of maturity, to get there. Which essentially, if we map it to that, very simple framework that I was showing, right? We are very much ready from a perspective of actions and visibility and insights, right? And the components that we have in our Crosswork portfolio very much fit into this idea of different domains and how to automate and provide insights on a per domain basis, etc. But now the next challenge is how do we address decisions, right? And there's one important point to also highlight, that when it comes to decisions, it's about decisions in the entire network lifecycle. It's not just, we tend to sort of implicitly think that, hey, AI will help us in making decisions when there is a problem, detect anomalies, do event correlation, and that's part of it, right? That's the reactive part of it. But we should not forget, and I think we have maybe underestimated the importance of the proactive part. All the other decisions that happen before a problem happens. Because if you have an infrastructure, when something fails, you definitely need to have real-time telemetry, real-time operational insights, be able to detect whether there is anomalies or not, be able to reduce the noise by correlating multiple events together, and eventually get to a root cause analysis and remediation. This impacts some of the key metrics that we usually talk about. Mean time to detect, mean time to innocence, mean time to repair. But there's a lot of decisions that happen before, right? That happen, when we design, when we build, when we create, when we manage the network, and that drive the behavior of that network. And in that process, influence as well whether the network fails or not, or how frequently it fails, right? And this is based not on real time, but more non-real-time insights. It's about identifying potential anomalies that are deeper in the infrastructure, or potential risks that we were not aware, right? Or also make better decisions, align decisions with our organizational goals. We've been talking this morning about sustainability. How do we make sure that the decisions we take on the network, design, paths, topology, and so on, are aligned with what our organization wants? That drives the behavior of the network as well. So ultimately, it's about taking better decisions. And what this influences is our MTBF, how frequently the network fails, right? And both are impacting directly the customer experience. So let's not focus only on MTTD, MTTI, MTTR. That's important, but let's also start considering MTBF and what can we do to prevent failures? What is the opportunity to act more proactively, okay? So a couple of example use cases. One, I will not spend much. You've seen it this morning in several of the presentations, the work that we are doing to provide deeper insights and decisions that optimize your infrastructure around sustainability goal, power consumption, emissions, et cetera, right? How do we make sure that the decisions that we take are aligned with our organizational goals in that sense? This is another interesting use case where we can use algorithms to surface risks on your network, what I call toxic factors here. Toxic factors that could be maybe a software release, or maybe a combination of a software release with some hardware, right? There's always things that might be working suboptimally, let's put it this way, in the network, and causing certain failures. Failures such as maybe interface flaps, or BGP issues, or connectivity issues, or authentication issues, or interoperability issues, right? And how to find what is causing that, or what is associated to those, right? So we have the data and we have the algorithms. We can bring them together to try to surface those risk factors. And if we identify them, then we can avoid them. If we can identify that, hey, this software version with hardware version is not working well, it's behaving toxically, right? Okay, let's avoid it, let's change the software, or let's at least be able to do something about it. And these are techniques that the AI toolkit, makes it available for us, let's say, to use them. It's just a matter of applying them. Generative AI. Who uses generative AI, like ChatGPT and so on a daily basis? Can you raise your hand? Yeah, probably 30, 40%. There's still 50, 60% here that are not using it. You should use it. That's my advice. But why is this relevant for us, in the context of networking, like, this type of language models? There are two aspects of this. One, mostly tactical, maybe short-term, low-hanging fruit maybe, and one that is more transformational. The tactical part is that language models, the way they have been trained, this idea of predicting the next token or the next word, basically makes them very good at anything, any task associated to natural language, right? And what happens is that in networking, we have a lot of forms of natural language that we work with. We work with configuration files, we work with log messages, syslog, and so on. We work with support tickets, we work with workflows, templates, YAML, JSON. These are all forms of natural language. So language models are very good at doing things with it, at interpreting the semantics, at being able to summarize, at being able to classify, maybe at being able to generate new. So you will see, both definitely from us and probably from others, how more and more use cases are developed in the automation products around leveraging LLMs with this type of data, because they fit very nicely, right? But there is some more transformative aspects of what LLMs give us in our context, and also in many industries as well. And it's about the concept of knowledge, right? Knowledge automation, or knowledge potentially in software. Knowledge is a kind of weird concept. It's difficult to define. I'm not going to read that, and I don't want you to read that either. But it's a sort of combination of multiple factors. It's about experience. Of course, it's about information. It's about connecting, context with experience, with data, understanding relationships, perception. So all those things together. And basically, that means that historically, knowledge has depended on people, right? Depends on us, because we are the source of knowledge. And when we need knowledge, we ask people, right? So that means it's an inherently scarce resource. It's limited, right? But what happens now, we have LLMs. And LLMs are effectively behaving as huge knowledge compilers. So a new form of knowledge, not exactly as the human, but in similar shape, it's available at the distance of a software API call. And that changes things a lot. Right? Something that was inherently scarce, now it's elastic, it's scalable, let's say virtually unlimited. Right? So the combination of knowledge coming from people plus knowledge coming from software enables us to rethink processes, to rethink paradigms, and do things differently potentially. So that is very transformational. What does that mean for us in networking? Well, maybe that might help us in this journey towards what we've been talking about, the autonomous network. We have the model and so on, but how do we get there? We're always talking about, hey, okay, we'll do more closed-loop use cases, we'll get to level 3, level 4, level 5, whatever that means, but what is new that will allow us to do that final step, if it will? So, we've been in a journey of making networks more and more software-based, like SDN in practice, right? And the actual trigger, the actual enabler for that process was the standardization of APIs. So the more standard APIs there are in the network, the more software entities were developed, right, that would interact and would configure, would act on those standard APIs. But at the same time, more network data became available, right, through those APIs. The consequence of this is more decision points on the network that software can interact with, and the possibility to optimize those decisions, of course, with data and some type of algorithms. And this is where we are today. We have an SDN, which is, of course, this is a very simplified view, but I told you my session was about, trying to bring things down into very, very simple concepts. This is where we are right now. What's new? Well, on one hand, cloud is new. So the cloud infrastructures, cloud resources allow us to do things differently or maybe new things. But particularly, LLMs are new. This thing didn't exist 2 years ago. Or it did exist, but it was not, at the, let's say, with the power that they are now. So if we take the LLM and combine it with cloud infrastructure and combine it with network data, now we have networking knowledge in software. We have truly networking knowledge in software that we can access through a software API call. That's new. We didn't have that before. We had rules. We could create rules, but we didn't have more complex, elaborated, dynamic knowledge. So with knowledge in software through the LLMs and all these decision points and the possibility to optimize those decisions, we have the opportunity to build autonomous agents. And I will explain that, what I mean, right? But these autonomous agents, in combination with the software-defined infrastructures that we have these days, set a clear path towards that ambition, which is the autonomous network. We didn't have this before. We couldn't build autonomous agents. We couldn't build networking knowledge in software before because we didn't have LLMs, but now we have them. So this is a new ingredient for our networking industry that sets a clear path that we can execute towards that end goal. What are these autonomous agent thing that I'm talking about here? We know about LLMs. You all know about LLMs. Some of you actually use them in your ChatGPT interactions and so on. And they are very good at responding to a question. An LLM is basically a mathematical function. You make a question, you get a response. That's about it, right? They don't do anything. They don't have productivity or anything like that. It's just a static mathematical function. But they are good at that, and they behave in a very imperative way, right? You make a request, you get an answer, right? And which is typically some type of summarization, translation, answer, etc. But now we can use LLMs as the brain of a more complex software system. A complex software system that is intended to solve complex problems, right? And how can it solve complex problems? Because it self-plans how to go about your request. You make a request, you state your intent, what you want, what tasks you need, and they can self-plan, they can build a plan. Okay, I'm going to do this, this, and this, and this to solve this request. And in that plan, they can execute actions and functions, right? So eventually, they can, as they execute autonomously this plan, they can provide you a response, right? When we think about intent-based management that we've been talking about, for many years, this resonates very closely, right? You state your intent, you don't define the how. Somehow the how is figured out automatically by the agent, and eventually it's executed, right? This is real. I mean, this is being explored in all industries, but there's a real opportunity in our industry to leverage these principles, these architectures, as a way to enable more comprehensive task automation, which includes both actions and decisions. But we don't need to stop here, because there's also multi-agent architectures where we can combine these things where agents talk to each other, right? Agents that might be specialized on different tasks, on different functions, or maybe you can have a swarm of agents executing a mission. It's just all possibilities, right? And it fits very nicely on how we could get to this end goal of the autonomous network. Just one example, right, of, and again, we can show this in our prototypes. Let's say you have a network and you have some BGP problem, right? And of course, you need to troubleshoot where is this coming from? Why is the BGP session down? Which could be for many different reasons. I mean, there's some configuration issue, there's reachability issue, I don't know, whatever. It could be many different reasons why a BGP session goes down, and you don't know, right? So you need to find out. And typically, a network engineer would go and troubleshoot this. So based on your experience, your knowledge, you would go step number one, I will do this. If it is not, then I will do this, and so on, right? But now we could have agents that do that on our behalf, right? You could ask an agent, hey, this BGP session is down, why is it? And then there will be a diagnostics agent that would plan, based on your request, how do I troubleshoot this issue? And it would produce a plan, right? And that plan would have step number 1 to N that would try to execute to find the root cause of why the BGP session is down. But this diagnostics agent will spin up other agents that will help in searching the information that is needed in each of the steps. So step number 1 maybe requires, hey, I need to have a look at the configuration, the BGP configuration on the two end devices to see if there is something wrong. So there is another agent that will be called to say, hey, find the configuration on these two devices. And this other agent will be specialized on that. So as part of that request, and because it's an agent, we'll plan, How do I find this? Well, there's a plan on how to search that information. And probably the first step is, what are these devices, right? Are these Cisco devices? Are these Juniper devices? What is this? What is the IP address so I can connect? So maybe it needs to check with the inventory first. And then once it has a response, then it will go and check. Same thing that you would do, right? In your logic to troubleshoot or to find some information. So the same thing we can expect or we could achieve with agents in collaboration to solve a certain problem, right? A complex problem for which otherwise you would need knowledge, right? Human knowledge. But now these agents, based on their little brain, which is powered by an LLM, they do have knowledge, right? So if we build this, and of course, this is still going to be a journey, and we're still some time. We will need to mature this. LLMs will need to get better, and so on. But I think it's promising what we can accomplish, and based on the results that we are getting. Okay. So then, if you think about that, this type of agents might become available, you could rethink the way we approach maybe network operations or the way we approach network automation in general. Because it's software, right? Of course, there's always limits in software, and of course there are costs and so on. But you don't even need to be limited to spinning up one agent. You could spin up 1,000 agents for a specific task. Of course, you cannot have 1,000 engineers, but what if you could spin up 1,000 agents to troubleshoot a problem, and they all will search in parallel, right? That could be an option, or 1 million. So, it's just possibilities, right? And there's a lot of different use cases that these type of agents could address. So it's just something to, also for you to consider, to think about how LLMs and architectures enabled by LLMs, like this type of agents, can transform the way we approach network operation and network automation in the future. And I think it's very promising. So what is the implementation journey then around AI ops and leveraging AI in the network or in the the network lifecycle? Step number 1, actions, right? We need to make sure that we have a strong automation framework foundation. And of course, we're doing it with our portfolio of automation products, especially NSO, workflow manager, controllers, etc. So that's also on you as well. Make sure in your journey that we have a strong automation foundation. And what we will see moving forward is that there will be more and more AI embedded into these systems, especially driving simplicity, helping you use those systems and accelerate processes as you use those systems so that it becomes much easier to automate multiple types of actions. Step number 2, insights. That's the other key foundation that you need to have. And you will see as well how the products will evolve or will expand, not only on the reactive side of insights, but also, or especially on the proactive side of it, right? So that we help you in the decisions that you need to take, not only when a problem happens, but also decisions that might happen before, and that will impact maybe how frequently or how less frequently the network fails, or how to align or optimize your decisions for your organizational goals, right? And last but not least, decisions, right? And how do we leverage the potential that generative AI brings to automate knowledge, to turn knowledge in software, and eventually use or start leveraging this concept of autonomous agents that might allow us to rethink the way we operate, the way we do things, or even transform the overall network automation, right? So this is sort of the journey, but just want to make the emphasis, the first 2, actions and insights. This is something that you can start doing now, right? Do not wait until you have all the mechanisms and techniques for decision automation. Because if you have them, but you don't have a strong foundation of actions and insights, you will not be able to fully leverage the opportunity. And just to finalize, right, we're at the beginning of this. This is especially the last part, the opportunities of decision automation, generative AI, and so on. We're in the infancy we've been only 2 years in, if you will, for many of these. But it's really promising, and I think as we go forward with network automation, we will see more and more that it becomes just a natural part of it. Probably the next instances of this event moving forward, they will have AI just as part of all the different topics that we discuss and that that we develop and that you deploy and implement, right? So thanks for your time. This is the end of my session. I don't know if there is any question or comment.
Yeah, go ahead. Yeah, we're going to display 2 questions.
Okay.
Do we need domain network specific fine-tune for LLMs?
That's a good question. I don't think there is a right or wrong answer to this. I'm going to give my opinion. I think we don't need them. I think the big LLMs today have already a strong knowledge. I think there might be a possibility to add more knowledge, but a lot of the additional knowledge that we can add could be added through other mechanisms that are not fine-tuning. Because fine-tuning for knowledge, right, which in some cases might be associated to fine-tuning for facts, right, might have a consequence that the model might forget previous knowledge. So I feel inclined to think that probably the big LLMs will be good enough for most of what we need to do. And we need to play with our domain area or domain-specific or company-specific knowledge bases using RAG techniques and others. But that's my belief at this point. We'll need to see if that changes or if there is a true need to have a network-specific LLM.
Okay. Second question. Are there any actual implementation use case that we can take a look at it and discuss, or is it a world presentation about possibility?
Mm-hmm. So when it comes to implemented, like deployed in production and so on, not much. But as I said at the beginning, all the concepts that I've shown here on this slide, talking about software upgrades, talking about toxic factors, preventive insights, talking about agents and so on. For all of these, we have prototypes and code, and we can demonstrate it. I mean, if any of you are interested, just reach out after the session, and we can definitely set up some time. But this is real. It's not just like a PowerPoint fantasy. But there's, for some of it, especially when it comes to the agents and the LLMs, there's still work ahead that we will need to, and research that we will need to do. But the results so far look promising. Yeah. Good. Thank you.
Thank you.